some properties of power set today discussed, and after that we will do exercise, then Venn diagram. So if A is a subset of B, power set we have seen, power set is the set of all subsets of a set. And if A is a subset of B, if A is a subset of B, then power set of A, power set of A will be the subset of power set of B. Obviously, power set of A will be the subset of power set of B. Okay, got it? For example, if A, suppose A is a set of element 1, 2, and A is a subset of B, so B is is a set of elements 1, 2, and 3. Therefore, A is a subset of B. You write the power set of A. Power set of A will have 5, 1, 2, all subsets of this set. 1, 2, so 2 raised to power 2, 4. So there are 4 elements in the power set of A, and power set of B will have 2 raised to power 3, 8 elements. So first write 5, then 1, 2, 3, then 1, 2, then 2, 3, then 1, 3, then 1, 2, 3. This is the power set of B. Okay. Now you can see this. This is belonging to this. All elements should be, so all elements of power set of A should be the elements of B. Then it is a subset. So 2 is there, 2 is there, 1, 2, 1, 2 is there. Therefore, this proves that power set of A is a subset of B. So this is first property. Second property, they should give after intersection and union, but I will explain it later on. You can note down this property, but you have to study now intersection and union. So just to remind me later on, I will tell you. Just I will tell what is intersection. Intersection means common element. If A intersection B means we are taking the common element. If you take common elements of A and B, or if you take intersection of the sets and then it power set, then it is same. Intersection means if we want to find A intersection B, here what is A intersection B? A intersection B is the common element 1 and 2. Okay, that we will study later on. For intersection and union means sum of these two sets. If you add these two sets, that is called union. So A union B is the sum of these two sets, that is 1, 2, and 3. Okay. Yes, BA is a subset of BB. BA subset of BB. Intersection means common element. This is called intersection. We will study. Just wait. For the time being, I am telling you what is intersection, but we will study later on. Intersection. This is intersection, and this is union. And intersection is the common element. If A intersection means we will take common element. 1 and 2 are common elements. Union means we will add all the elements. So union is addition. Intersection is the common element. So intersection of the two sets, power set of intersection of two sets, or intersection of the power set are equal. This we will study. Huh? Similarly, for union also, power set of A union B means first we will find A union B and then its power set, or if we find power set of A and power set of B and their union. You can prove here also. See here. Here, first, the second part, power set of A. Power set of A intersection power set of B. Means A and B. Power set of A, what is power set of A? This intersection of power set of B, this is power set. Their intersection is common element. So common element will be set A only 5, 1, 2 and 1, 2. These are the common elements in power sets of A and B here. A and B. And now you can see this A intersection B. What is A intersection B? This is A intersection B. Then find the power set of A intersection B. Power set of A intersection means you have to find the power set of A intersection B is 1, 2. What is the intersection means power set of A intersection B? That is 5, same 1, 2, and 1, 2. Okay, so both are same, therefore it is true. Similarly, for union also you can do it. Okay, so now we take one question. If question is if A is a set of elements 1, 2, and 3, then find, this is very simple question, then find the power set of A. Find the power set of set A. Okay, so making power set, first we will write all possible subsets of A. Okay, all possible subsets of A having single element, having double element. Okay, or you can write directly. So all possible subsets of A. All possible subsets of A are, first always write null set, then we will take one element, single element, sets of single element 1, 2, and 3. Sets of two elements, set having two elements, so we can have the possible combination of 1, 2, 2, 3, yes, correct, 2, 3, 2, 3, yes, yeah, correct, 2, 3, and 1, 3. 1, 2, 2, 3, 1, 3, then 1, 2, 3. Also check how many subsets are there, 1, 2, 3, 4, 5, 6, 7, 8. And how many elements are there? 3. The 2 raised to power 3 is equal to 8. That is correct. That means they are not left. Therefore, the power set of A, therefore, the required, like this, you should write required power set is denoted by P, capital P, A, and we have to make the set of all these sets. So, in power set, all elements are itself set 1, 2, 3, 1, 2, 2, 3, 1, 3, and 1, 2, 3. Okay, got it? So it is not a subset. Okay, yes, correct, Afra. So then it is not a subset. Similarly, the sixth one is a subset. So equilateral triangles will come in triangles. X is an even natural number, X is an integer. So even natural numbers all will come in integers. So it is a subset. Okay, got it? Question number 2. Examine whether, question number 2. Examine whether the following statements are true or false. So first statement, AB is not a AB is not a subset of, but it is a subset. Okay, so it is false. A, X is a vowel in the English alphabet. Okay, A, E are the vowels, so it is true. 1 to 3 is a subset. No, wrong. 1 to 3 is not a subset because 2 is not there. So this statement is false. Then A, here, this is false because A is a set. Here you can see this is very important. Here it is written set A. Set A is a subset of A, B, C. Set A is a subset. So correct. So this is used for subset. Yes, it is a subset of this. True. And belongs to, yeah, this one, fifth statement. But if we write this belongs to, this is wrong, false. Because element belongs to, A belongs to, set will not belong to this one. Only set belongs to the power set. Okay, so that is false. X is an even number and it is a subset of natural numbers which is divisible is an even number less than 6. Even numbers less than 6 even numbers are 2, 4 and 2, 4 is that which divides the number 36. So 2 and 4 both divide the number 36. Therefore, it is also true. Then we have which of the following statements are correct and why. The reasons, I told you the reasons. You can write down the reasons directly, but we are doing the question here. Which of the following statements are correct and why? First statement. First statement is 3. Here it is given. You have given the sets, correct? Set A, but in set A, here it is a different type of set. Two are elements, and one element is a set itself, and then again you have five. This is set A. Now on this basis, you have to tell whether 3, 4. Now 3, 4 set 3, 4 is an element. Set 3, 4 is not a subset of A. Okay. If you will write this like this, 3, 4 is 3, 4. You will write inside the set. Then it will become a subset. Then it is true. Hmm. It is false because 3, 4 is an element. Element cannot be a subset. The reason, what will you write the reason? Because 3, 4 is an element. Hmm. An element cannot be a subset. Second, 3, 4 belongs to. Yes, it is correct because 3, 4 is an element. Now, element can belong to the set. 3, 4 belongs to A is correct. This is correct. I'll write true. Correct. No? This is false. And the third one I have written here. This is correct. The third one is correct statement because this is having an element which is inside the set A. So this is a subset of A. It is true. Then one belongs to A. Yes, this is also true. One belongs to A. One is an element and it belongs to A. Is true. So fourth is true. Fifth, false. Sixth, 1, 2, and 5. Yes, it is a subset. Correct. 1 to 5. Seventh, false. 8, false. 9, 5 is a subset of every set. True. 5, no, no, no. 5 belongs to A. No, no, that is wrong. 5 is a subset of A. It is true. and subset of phi is a subset of A. Set of phi is a subset of A. That is correct. That is incorrect. Sorry. That last point, 11th point, is incorrect. Hmm. Next question is write down all the subsets of the set and how many sets are there. Write down all the subsets of the following set. You know that how to write the subsets of the set. These subsets of this, subsets of this. You know that phi and A, it will have 2 raised to power to 4 subsets, and this also, and other also. You know that. How many elements has PA if A, this also we have done. If A is equal to null set, then PA will have only one element, that is null set. Okay, so one element like this you can write. So converting into set builder form. Hmm, now you can see this. Write down the following as intervals. This we have done. Correct. This we have done. How to convert? I will tell you one of that answer. This is minus 12 to 10. So both are excluded. So we will write it is an interval where minus 12 and minus 10 both are excluded. And write in the set filter form, you know that this is excluded. So you will write it as a set of all x such that x belongs to R and x is included. So greater than equal to minus 23 and less than 5. This is the set filter form. Write the universal set of right triangles. So universal set will be the set of triangles. Set of isosceles triangles also the set of triangles universal set. Given that which of the following may be considered as the universal set? Yes, all should come. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. After 6, 8, 7, 8, 9. 9 is not there, but 6, 7, 8. So we can have 1, 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. This will be the any 0 is also there. This is not there. Because 0 is also there, so we have to take the 0 with 0, but 8 is not there here, so we will take this one. Third will be the universal set. Universal set means the set which contains all the given sets. It contains all the given sets. Okay, now we will start Venn diagram. Now we have to start Venn diagram. Venn diagram, huh? So what is Venn diagram? Venn diagram is nothing but it is the representation of the sets, diagrammatrical representation of a set. So Venn diagram is very important thing, will help a lot for solving the question. So Venn diagrams, in Venn diagram, universal set is represented by, if we have four sets, three sets, and their universal sets are given, and we have to draw the Venn diagram. So you can just note down that in Venn diagram, I will show you one. I will write it. When in Venn diagram, the universal set is represented by always. You cannot make any other shape. So for universal set is represented by, universal set is represented by by regular region, by rectangular region, by rectangular region. You have to draw the rectangular region. So rectangle, you have to draw the rectangle. So rectangular region, by rectangular region, we will represent universal set. And inside this, we will represent subset by using circles. So then its subset are represented by, are represented by circle. Okay. And also an element inside the circle, inside the sets elements, we can, if we have finite number of elements, so of a set an element of a set is represented by a point, is represented by a point inside the circle, represented by a point in the or inside the circle. For example, if you have one, you have a universal set, okay, it can be any number, 1, 2, 3, 4, 5, 6, 7, 8, and you have two sets. A is a set of elements 1, 2, 3, 4, and B is a set of elements 3, 4, 5. We can have more sets also inside. So big we will draw one big rectangle which will represent the rectangle. Not this much big, just we can draw one rectangle, and at the end of left side, you can write here, this is a universal set. Okay. Now universal set means it has all the elements 1 to 8. As it is here, the universal set is 1, 2, 3, 4, 5, 6, 7, 8, and set A, set B. Now we have to draw set A and set B by using circles. Now you have to check that A and B has some common element. So we will draw set A and set B by using circles. Okay. Chalo. We can draw by three hands. But you should use to draw exact circular figure. This is set A, and they have common elements. So we used to draw like this if they have common elements. Can be any means bigger or smaller or same side. It doesn't matter. Huh? This is set A. You can write that A inside, or sometimes we are writing on the top of this. This is set A. And this is set A and B has 3 and 4 elements. So this is 3. Here you can show 3. Here you have 4 because 3 and 4 are common elements, and 5 is here. 5 is in B. So 3, 4, 5 belongs to B, and 1, 2, this point 1, 2, 3, 4 belongs to A. So this is the Venn diagram of showing this figure. This is the Venn diagram of this figure. We have shown diagrammatically the given condition. Okay, understood? And if A is a subset of B, we will draw A inside B. B is a subset of A, we will draw B inside A. Okay. Now we have operations on sets, then we will understand better about this intersection and union. So operations on set, that is union and intersection. There are two types of operations on set. Yes, yeah, yes, correct. 1, 2, 3, 4, 5, and 6, 7, 8. We can write 6 anywhere, 6, 7, and 8 anywhere outside these because it belongs to universal set. But sometimes it is difficult to represent the point. Here we have finite number of points. If infinite, we no need to represent outside elements or inside elements also if they have more number of elements. Okay, only the diagram is should be proper diagram. So operations, now we have operations on set. Okay, operations on sets. So as I told you, first is union of two sets. The operation union. Operation means plus minus. In other numbers we have, in simple numbers we have plus minus operations. Here between the sets we don't have plus and minus like this. Here we have union of two sets and intersection of two sets. So union of two sets, how we will define, let means both elements should be written together for A and B. So let A and B be any two sets. Any two sets. Can be any set. Okay. Then the union of, now see this is very important wordings. The union of A and B is the set of all those elements which belongs to, or means union is or, just remember this is for or. Okay, union is used for or, which belongs to either A or B or both. Now see that some element, that means in union some element will belong to A, or some element will belong to B, or some element will belong to both. We can see the example. For example, if I take A is a set of, if they have element common, then both 1, 2, 3, and B is a set of 3, 4. Okay. Then we have to find A union B. So A union B, we have to mix the element. These all together, right? But 1, okay, 2, 3 we cannot write 2 times in set. One element will be written one time, whether it comes in 100 times. So 1, 2, 3, 4 is the union. Now you can see that 1 belongs to A only. Correct? 2 belongs to A only. But 3 belongs to both. Both. 3 belongs to both A and B. So this depends. If they have common element, then some element will belong to, or maybe all will belong to A. If A is a superset of B, then all will belong to, but some element will belong to A and B both. If they have common element, they don't have common element, then either A belongs, some element will belong to A or B. Okay, so this is the definition, and it is denoted by, as I told you, union. So it is denoted by and read as A union B. It is denoted by, is denoted by A union B. A union B, and we read as A union B. No need to write. The symbol is used to denote the union. So this is used to denote union, as you know, to denote union, to denote union. Okay. So as I told you when I was teaching universal set, that's why I told you for universal set use this one. For union use this one. Okay. These two are different symbols. This is for universal set. So therefore, in symbolically we can write A union B. This is set of all X. That's why OR is coming very important. OR is very important. X is a set of elements A or B. We will not write both, but can be both. X belongs to A or X belongs to B. Union means the element either belongs to A or B. Correct? I have given you the example, you understood. Find the, if sometimes union, okay, this is the union. The question will be very simple. I'll take one question very easy. Find the union of.